Hello guys, this is Kavya from Manifold AI Learning, and in this video series I'll be outlining certain techniques for the efficient loading, storing as well as manipulation of data in Python. So guys, let me tell you this, and please believe me, this is a very vast topic. And do you know why? Because in the real world, we come across many data sets which come from a very wide range of sources, actually in very different formats, wherein it also includes the collection of many documents, images, some numerical measurements, and even the sound clips. So, with this obvious diversity in content, we'll take our thought process in a way where we think of all the data fundamentally as array of numbers. Yes, of course, initially all the data is considered as array of numbers. So, to give you an example here, so guys, just think about the images that to a digital image which is composed of picture elements which is known as pixels. Okay, so now you can just think these digital images as a two-dimensional array of numbers which are representing the pixel brightness across the area. So in the same way, you can think of the sound clip, sound clip or the audio clip, which can be thought as 1D array of intensity versus time. And now we have a data in the text format. Of course, we can get the data in the text format, wherein the text can be converted into various formats like binary digits representing the frequency of certain words. So what I'm trying to convey is, no matter what the data are, the first step is all about analyzing the data is to transform the data into array of numbers. I repeat here, this is very important. So what I'm trying to convey is, no matter what the data are, the first step in analyzing the data is to transform the data into array of numbers. So now, for this reason, I can say as the efficient storage and the manipulation of numerical arrays is the very fundamental step to the process of doing data science. And of course, there is a huge library of Python which contains several packages which are already developed and immediately available for the programmers. And these libraries are also called as batteries included. Yes, it is called as batteries included. So now, one such specialized tool or the battery that Python has for the handling of numerical arrays is called as NumPy package. So guys, this video series will help you to get familiar with the widely used library in Python, that is numerical Python or NumPy. So this NumPy actually provides an efficient interface to store and operate on dense data buffers. That is, you can efficiently use this NumPy for the statistical analysis. And in one way, I can say as these NumPy arrays are like Python built-in list type. But guys, let me also tell you this, that is, these NumPy arrays provide much more efficient storage and the data operation, that too when we have the arrays of very large size. And one more thing, that is, when you compare this NumPy with the Python list, then this NumPy uses very less memory to store the data. So to illustrate this, let's do some coding over here. And guys, for now, you may not be able to understand as what I'm writing, but don't worry. Just be with me and observe the output carefully. So you will get it as what we are doing. Okay? So let's come to our Jupyter notebook. So here I'll write as import NumPy as NP and then import sys. And then pylist is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 5, 6, 7, 8, 9, and 10. And then NumPy array is equal to np dot array of, again I'll be sending this list 1 to 10. 1 to 10, same list. And then size of Python list is equal to system dot get size of 1, and it is multiplied with length of PyList, that is Python list. Then size of NumPy array is equal to NumPy array dot n bytes. Okay, then I'll be writing two print statements here. One is size of Python list and another print statement for the size of NumPy array. So before executing, let me brief you as what I'm doing here. That is, so here I have created a simple Python list of 10 elements with numbers, that is between 1 and 10. And here, along with the Python list, I have also created the NumPy array with the same elements. And after that, I have written the code to display the amount of memory occupied by the Python list and the NumPy array. So let's execute this code cell. Okay, now if you observe the output, then the Python list is having the size of 280, wherein the NumPy with the same elements is of size 40. So guys, this confirms that the NumPy takes very less memory when compared to that of Python lists. Okay. Now, apart from this, I can say as these NumPy arrays are great for the numerical operation, wherein the Python list cannot directly handle the math operation. See, I'm not telling as like the Python list cannot handle the math operations. I'm telling you like this NumPy arrays are very great for the numerical operation, but Python lists are not that efficient. Okay, so to give you an example here, what I'll do is I'll just take up an array and then I'll divide each element of an array by some number. Okay, now to do this operation in the NumPy, I'll be taking only a single line code. Okay, just to show you this, let's start coding and you will get to know as what I'm doing. Okay, so the first line will be like x is equal to np.array of let me send some list like 5, 10, 15, 20, 25. 5, 10, 15, 20, 25 and 30. Afterwards, I'll be dividing this array by 5. So div is equal to x divided by 5. And then of course for the print statement, solution is and then div. Okay. Yeah, let me execute this now. See, I have an array of elements and then I am just dividing it by 5 and then I got the output. Easy. Here I have used only a single line code. If you observe, I have given the input and then just like a simple calculator, I am dividing by 5 and I got the output. Now, what I'll do is I'll just apply the same method for the Python list, that is like dividing directly by 5. Same thing, okay? But I'll be using Python list this time. So PyList, same elements, and again I'm dividing in by same list, and again I'm dividing it by the 5 and same old print statement. That's it. So let me execute this. Oh, what is this? We have an output but an error where the message says unsupported operand types. That means this division is directly not possible with the Python list as we did with the NumPy. Guys, I'm repeating here, that is, please don't misunderstand. That is, it doesn't mean that mathematical operation with a list is impossible. Of course it is possible. It is like you have to follow certain steps, like at first you should be initializing the blank Python list and then performing the desired mathematical operation, and after that you should be appending this result to the Python list. Yeah, these many procedures includes when you want to do certain mathematical operations on Python list. But with NumPy it is very easy. But with Python list it is possible, but not as efficient as NumPy. So guys, collectively, I can say as if you're planning to do any numerical operation with your combination of items, then please consider using this NumPy array. Okay. So I feel like we have got very good reasons for learning this NumPy library. So what are we waiting for? Let's dive deep and understand to the core. Okay? Yes. So guys, this NumPy library doesn't come with the Python by default. So to access this NumPy library, one of the easiest way is to install the Anaconda distribution. Here I have already installed this Anaconda stack. So we have this NumPy installed and ready to go. Okay. So now what I'll do is let me just open a new notebook, that is new Jupyter notebook. And the only thing we have to do is like importing the NumPy to our notebook. So what I'll do is I'll just write as import NumPy. Okay, and execute this. Yes, I have imported the NumPy library to my notebook. Now let's just check the version of the NumPy which has been installed in our notebook, installed in our stack. That is NumPy dot underscore underscore version underscore underscore, and execute this. Yes, the version we have here is 1.18.4. Great. So guys, with this, we got to know one thing. To work with NumPy, we should first import the NumPy module into our Python notebook, like we did it here, that is import NumPy. But guys, you will find that most of the people will import this NumPy using NP as an alias. That is, import NumPy as NP. I think you might have observed it many places, like they don't just import NumPy, but they'll be importing the NumPy as NP. So in the same way, we will be also doing the same way, and throughout our learning journey, we will be importing the NumPy in the way that is import NumPy as NP only. Okay? Nothing scientific reason behind it. It is just like every time when you want to make any operations, or when you want to use this NumPy, every time typing NumPy all the time, it will be a rigorous process. So we are using just alias of NumPy, that is NP. That's it. You can use anything. Import NumPy as apple, import NumPy as orange, import NumPy as mango, anything. But here, as every people do or everybody do, we are using NumPy as NP. That's it. Okay. Enough of this. Now moving ahead, let's discuss something about this array or n-dimensional array. Let me tell you this. This is a very interesting thing. So in Python, the arrays which are created from NumPy library are called as n-dimensional array. Yes, it is called as n-dimensional array or ND array, wherein this n can be any integer. So if this n is equal to 1, then it represents 1D array. And if this n is equal to 2, then it represents the two-dimensional array. And in the same way, if this n is equal to 3, then it represents the three-dimensional array, and so on. Got it? But here I want to state one more important thing, that is the arrays created in NumPy can accept only one type of elements. That means we cannot store different data types into same array. Got it? Great. So now to begin with, let's understand the concept of array object. For that, what I'll do is I'll just come back to my Jupyter notebook, wherein I'll be creating an array so that you can get an intuition as how it looks like. Okay. So to my Jupyter notebook again, and here I'll just, since we have already imported the NumPy, I'll be printing an array over here so that you get to know as how it looks like. So it will be like print of np.array of. I'll be sending the Python list over here like 1, 2, 3, 4, 5. Okay, and execute this. See, the array which I have created over here is called as 1D array. So you can think of this one-dimensional array as a column or a row of a table which contains one or more in it. Okay. Now, apart from the single-dimensional array, we also have multi-dimensional array. So now to get an idea on this multi-dimensional array, what you can do is you can just think of an Excel spreadsheet. I hope everybody have seen this Excel spreadsheet, correct, right? So you can think of this Excel spreadsheet wherein the data is in the form of rows and columns. And guys, this is the perfect example for the 2D array. So now to illustrate as how this 2D array looks like, what I'll do is I'll write the code in this fashion, that is arr2 is equal to np.array of, I'll be sending two lists over here, 1, 2, 3, and another list that is 4, 5, 6, and then print 2D array arr2, and another print statement I'll be writing, that is to know the shape of an array, okay? So that will be print of arr2 dot shape arr2 dot shape. So guys, for now, please don't worry about the coding part, but I want you to observe the output carefully, because I'll be telling you each and everything as why we are writing all these things, okay? For now, please don't worry if you don't understand the code, just observe the output, okay? So let me execute this. Great. As you can see in the output, the array which I have printed is having 2 rows and 3 columns. That is, the shape of an array is 2, 3. So guys, I hope you now have an idea as how this 1D and 2D array looks like. Now the question is how we can create an array using NumPy. Actually, there are 5 general ways for creating an array in NumPy. First is creating arrays from the Python structures, that is by using tuples, lists, and range objects, we will be creating a NumPy array. Okay. Now the second way is by creating the arrays from scratch, that is by using intrinsic NumPy array creation object, that is inbuilt array. By using inbuilt functions, we will be creating the arrays like using arrange, ones, zeros, linspace, and many more. Okay. After that, another way is like we can create the arrays from raw bytes through the use of strings and buffers. And finally, we have got certain special library functions available for the creation of array. And here, this random will be the best example for the special library function. Yes, by using the special library functions also, we will be creating the array using this NumPy. Got it? So guys, these were some of the ways for creating a NumPy array. So this was all about for this video. So in the next video, let's see as how we can create an array using Python structures. So till then, happy learning and stay safe. See ya.